Yeah, I thought I would use the chance and talk a little bit about my daily life as a data scientist and one of the typical projects that we basically have every day. And as you can see, I have a quite fancy title, Competence Lead, Data Science and Machine Learning. Maybe tell you in one sentence what this actually means. It basically means I live the dream now I always had when I was a little girl. You know, I'm at the moment traveling virtually around the world, and talking about mathematics, every day. I think some of you might share this dream. Yeah, maybe you also had them when you were little girls. I heard it's quite common for tiny little girls. So maybe, this will also be your road to become a data scientist or a machine learning expert. Yeah, so why did I choose this title for our error log file social? I hope you will find out during my session. I would like to start with something which typically comes as a request from our customers. Yeah, we have some customers who come to me and say, Sarah, we want to do predictive maintenance. Okay, and I say, let's investigate. Let's have a look at that. So most of the time they have certain machines, which are producing some stuff. And what they want to do, they now want to have some data science, machine learning magic, who's taking all the data they have into consideration. So taking the sensor data that they measured and also the master data they have about the machine. How old is it? When have been some spare parts here been changed and so on. Yeah, so we take all this data, then we train some algorithm, and then our machine learning magic should predict us whether the machine will fail soon. Yeah, so there might be a sad face, or whether it will be working for the next couple of months. Yeah, so they want to know this in advance, and they ideally want to know when will be the next time the machine will fail us. Yeah, so much for the theory. It's an actually quite common use case, and I think it's a quite valid one. So what are now the problems we most of the time face? Yeah, our customers are usually really proud and say, yeah, we have 10% of our machines have now some sensors attached to it. And it's like, okay, 10%, that's not much. How long have they been with the machine? So how long have you been collecting data? And they're proud again, like last 4 months. And I say, okay, good work. And how often did the machine fail? Because this is actually what we want to learn. Yeah, how often did it fail so that we can predict when will it happen the next time? And then I say, just 2 times. I say, okay. Yeah, I mean, that's good for you, but from a data perspective, that's not so good for us. Yeah, because how would you find patterns when there are so rare events that just happened 2 times? Yeah, so what you're going to tell to the customer? You could either tell it, make the machine break more often. Usually not what they want to hear. Or you can say, come back, when you collected more data. Sorry, guys, but again, this is something which they also don't want to hear. Yeah. So what I then usually do is I take a step back. Yeah, and then I say, okay, dear customer, let's have a look at what kind of data do you have? Yeah, and what they always have. Yeah, like I said, they don't have that much sensor data and also not much other data. What they always have are some error log files. Yeah, and the good part about this error log files is that they're written by a machine. So you don't have the human factor, which usually leads to bad data quality sometimes. Yeah, they're written by machines, so they're a bit more reliable and they always have the same structure and so on. Yeah, and this is something basically every customer head I talk to. Yeah, every machine is, while it is producing some stuff, they're writing these error log files. Yeah? So whenever something fishy appears in such a production cycle, the machine will write it into the error log files. So you have a list of all the errors and warnings and everything which appears, which is quite good. Yeah, and this is some semi-structured data, which means in this case, it's not completely unstructured. So it's quite simple to put it into a form that the machine learning algorithms can use it. Yeah, so the data preparation, which usually is 80% of my time, sorry to say that, as the main work, is in this case quite simple. Yeah. So what do we actually need? I have here the concrete examples of the fields we would need in the data. We need a unique production cycle ID. So this means for the time when one product is produced, we have a production cycle. This is what we need. Typically, this is standard. This is written in such files. And then, of course, we need the error code, which, of course, again, is stated in the files. We might have some other things, some timestamps, short description. This is optional. Yeah, but sometimes they're there, sometimes they're not. But if they're not there, then that's also fine. Yeah. So, and what would I use this for? Yeah, since now we have this data, I thought, yeah, okay, so we have here a connection. We have a production cycle ID, and this production cycle tells us what happened, each error and warning that happened during this production cycle. And I thought maybe we could use the same mathematics we all know, yeah, which is often used in retail. Yeah, just think about Amazon, for example. When you there buy a certain product, yeah, it gives you some recommendations and telling you other customers who are interested in this product also were interested in this, this, and this. Yeah. So you build here the connection between a customer and the purchased product. And what we do here now is actually we build a connection between the production cycle and the error code. Yeah. So it's really the same mathematics we typically use in retail. We can now use here in the manufacturing area. Yeah. And how does this actually work? Yeah. So the first thing is we check for each production cycle which errors and warning appears together, yeah, in one of these cycles. And with this, we build such a network. Yeah. So let's have a look. We start with our errors and warning. Here are some pictures of the errors and warnings that could appear. And then we map it here together with our production cycles. And then what we do is we build basically a graph. Yeah, so that we here find some connections for each of the production cycles, which errors and warning did appear. This is the first thing. So in each production cycle, we check which errors and warning did appear. Now it could happen that in some of these production cycles, we only had one error and warning appearing. These are the ones in this case, which are not so interesting for us. Yeah, I mean, it's good. Yeah, the less errors and so on they appear, the better for our production, but for our analysis, it's not so important. So that's why we filter that out. So we lose some of the connections because there were only one appearing. But now we can focus on the production cycle where there was more than one error and warning appearing. Yeah. And then what we want to do is now, based from this analysis, from this graph or linked analysis, how we also could call it, yeah, that we build, we now can extract a second graph. So now we can find, based on the probability, how often it happened, yeah, we can now say, okay, which of these errors or warning appear together in one production cycle? And of course, the more often it happens, the stronger is the connection. Yeah, here I have some weaker connections, I put them out in gray, and the other ones are here in darker blue. Yeah, so this then is now our graph. Of course, we can sort it a little bit, yeah, because then it actually looks like this. Yeah. So now we can see here we have 3 of our errors and warnings, which here appear in a in a triangle. So they often appear together. Yeah. So they basically, when you know one of these is happening, it's quite likely that the other ones will also appear. Yeah. And then we also see on the right side, there we have a more complex structure. And what I can do now, also on this graph I now created, I can use a second algorithm to find some clusters. So now I can group it. Yeah, so I can combine this also with typical, yeah, these 2 algorithms. Now I can combine it. So in this case, we now here have 2 different groups. Like I said, on the left, the 3 error codes that often appear together. And on the right side, we have here these 5, which are also grouped together. This gives me also some more insights about how certain things are influencing each other and how they are connected. And what I now could also do is I can, since we now have this group, I can also categorize my error log files, my error or warnings. So here, for example, if we have the little bug who's appearing, yeah, then I know, okay, it's quite likely then that it will go to our error or warning to the right. Yeah, it's the most likely thing. But there's still a chance that it will now not only leave me with another error or warning within the same group, but it will also could maybe result in an error that will end up in a second group. Yeah, and if this happens, then it is more likely that I will have 2 more other errors or warning also appearing. Yeah, and in retail, something like this is called a bridge product. And this is something that you also see sometimes from Amazon. These are products, yeah, when you shop, for example, in a certain product category, that they will suggest you something which also gives you into a bridge or group into another group. Yeah. So for example, if you're only searching for some books in the fantasy area, then they could suggest you something from the fantasy area, but might also lead you to another genre. So you could also be interested in maybe purchasing more books into another group. Yeah. And here it is also quite interesting to check on these bridge errors or warnings, because they could result even into more errors and warnings later on. Yeah. So they are really, really interesting, and we would also try to avoid them. Yeah. So what are we using this for now? Now we have this analysis, and now we can basically do the same thing as we did or as we see on Amazon. So imagine you're the person who's regularly doing some checkups on the machine at the beginning. Yeah. So you're checking the machine, you're maintaining it, you see if everything is okay. And sometimes it can happen that you have to maintain a machine because a certain error or warning happens. And usually then, you as the mechanic would just go there and then inspect for this certain error and warning. And then a short time later, as you can see, some errors don't come alone. They usually are quite likely to have, on a shorter time frame later on, also more other things happening. You have to do it again due to the next error or warning. So what we can do now is, when you maintain the machine, the mechanics will get a list. Yeah. So they will get a list with the top 10 most likely errors or warning that will appear in a shorter time frame. Yeah. And due to this wonderful grouping that we have here, we can now even tell them, okay, is it a bridge to another group, which then might even lead to more problems, more errors or warning, or is it just a regular error or warning code? Yeah, so that they know what they could also check. And especially, like I said, these bridge errors are quite important, because even if it's just 10% that they might appear, it might be still value to check on them, to avoid the other things that they may be causing. So in the end, doing this, with these wonderful recommendations that you get when you have to check the machine anyway, on a regular checkup or due to some errors or warnings that have appeared, we now can lengthen our inspection cycles. So you now don't have to do it that often, because you're preventing some things from happening. And so this is of a big value in this case. And the customer was actually quite happy. I had a really funny discussion with some of the mechanics. When I first gave them their recommendations, on what they also should inspect with the machine, then they directly came to me and said, like, oh yeah, Sarah, this is really interesting. I always thought that this thing was connected to this one. You can even hear it when you stand close to the machine. You as a physicist, And I was like, yeah, sure. I couldn't bear it to tell them that I actually have my diploma in theoretical physics. But they were really happy with that, and they really liked it. So it wasn't originally what the customer wanted to do, but in the end it was a big success. And what we did here is we did really approach from data driven. We checked what kind of data does the customer have, what can we do with it, and so in the end we generated some great value for them. And with this, I would like to hand over to our organizers, and I'm really looking forward to your questions.